Hey guys, welcome to 4.2 for science. Before we get into 4.2 today, we need to check our 4.1. You need to show me evidence when you send me the video that you checked your 4.1 so that I know that you're watching the video as well and not just adelantando to the next thing, because you need to make sure that you understood what you learned in 4.1, which means you need to know that you got the concept review right and the application. If you did not understand how to do them, you need to correct them or you need to write down the process that I show you. Okay, here we go. Let's look at, so we're on page 89, section review 4.1. Number 1, what two principles of the kinetic theory of matter are essential for the study of fluids? That was at the very beginning of the section. It is that the two principles that all molecules of matter are in constant motion, and that the warmer the molecules are, the faster they are moving. That's on page 83. And then number 2, what is the difference between cohesion and adhesion? Cohesion is when there's a force attracting molecules of the same substance. Okay, so if it's the same and they're attracted to each other, that's cohesion. Adhesion is when two different substances, molecules, are attracted to each other, like glass and water. Okay, number 3, what phenomenon causes a liquid to act as if it has a thin film on its surface? That would be surface tension. Number 4, what phenomenon causes water in a narrow tube to rise above the water around the tube? Capillarity. Number 5, what is pressure? That's the force exerted on a certain area. Okay, because there's different types of pressure, so you can't say that it's what the air does or water, etc., because there's different types of pressure. Number 6, state Pascal's principle that in a fluid, if pressure is exerted, that pressure is felt equally throughout. It's equally throughout the liquid. Number 7, what machine is a practical application of Pascal's principle? Remember, I told you before, anything that has a pump. You know, your office chair that goes up, 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 the chair in the salon, the thing that raises a car's tire so that you can get under the car and work on it or fix the tire or anything like that. Anything that involves a pump would be a good principle for Pascal's principle. Okay, number 1 for application. Christopher has a container of water that is shaped like a rectangular prism and is trying to determine the pressure on the bottom of the container. He already knows the depth of the water. Does he need to know the area of the container's bottom to determine the pressure? Why or why not? The answer is no. If you go to page 86, you will see that there's already a lot of pressures calculated from just depth and not area. Area does not matter because it's wherever the pressure is, it's felt throughout the entire liquid. Okay, so that area will not matter. Okay, number 2, unfortunately, they never talk to you about specific gravity. So if you didn't get this question right, really not your fault, to be honest with you. But you could be like, some of you guys go and search for it anyway, which is perfect and teaching a lot more than just waiting for the book to teach it to you. So that's great. But I'm going to show you the answer. The specific gravity of liquid hydrogen is 0.07. Okay, so we're going to need to know that number. I'm going to treat that number like a fraction of something. If the pressure of the water at the bottom of the 15-meter deep tank is 147 kilopascals, what would the pressure be at the bottom of the same tank if it were filled with liquid hydrogen? So basically what we're saying is that this is liquid hydrogen is 0.07 density or pressure of water. So we're just going to multiply that by the kilopascals to get the fraction of the pressure of water that liquid hydrogen would be, and your answer is going to be 10.29 kilopascals. Okay, so that's all you do. You just take the 0.07 of that. That's what specific gravity is talking about. Number 3, an engineer is designing a hydraulic press. The small piston will have an area. I'm already going to know it's going to be force. What is it? Force over area of the input equals force output over area output. Okay? As force gets bigger, the area gets bigger. As area gets bigger, the force must get bigger. Okay, that's the relationship between those two. So it says a small piston will have an area of 5. The press needs to have an output force of at least 700 when the input force is 300. Whoops, input force. What is the smallest area that the large piston could be? Okay, so we're looking for this right here. So we're going to go 300 over 5 equals 700 over A. I'm going to crisscross and multiply that, so it's going to be divide over here. 35 divided by 3. Your answer is going to be 11.67. For that's how small the area can be of the output. Okay? And that is it for 4.1. Okay, moving into 4.2, you're doing the entire section today, which means you need to do the review at the end. I'm going to give you the requirements as we go through it, okay? Now we're going to start talking about gases. So this is not a liquid, but it is a type of fluid, right? But it's the other state of matter. The first thing that you need to talk about is give me 2 sentences on what compressibility is. What is compressibility? And compressibility is really easy to understand. It's just that you can take gas molecules and you can make them into a smaller volume, because gas molecules have a lot of space in between their molecules. They're bouncing off of each other, and they don't have a lot of pressure on them. Okay, but if you put the pressure on them, you can really reduce the amount of space that they're taking up because there's so much air in between their molecules. It's good to understand that, to understand the laws that we're going to talk about today. So the very first law that we're going to talk about today is Boyle's law. Boyle's law. You need to give me 5 sentences on Boyle's law, telling me what it is, telling me what the formula means, and telling me what the relationship is between pressure and volume, okay? Boyle was another Christian scientist. You'll read about him on the next page, okay? He was another Christian scientist who came up with the formula of P1 V1 equals P2 V2. What he discovered through scientific experiments is that when you keep temperature the same, okay, you're going to learn that with all these laws, and I know that you learned it one other year before, so this shouldn't be super new for most of you. You have pressure, when you're studying gases, you have pressure, volume, and temperature, okay? You have a relationship between these 3. But when you have a relationship with these 3, there's always one that you're going to keep constant, which means you're not going to change. When you keep one of those constant, you take it out of your formula, okay? So if you want to know what formula to use, you have to know what is constant. So for example, if I say, okay, in this experiment, we're going to keep temperature constant, that means that the only things that are going to change are pressure and volume, and you need to use the Boyle's law that involve pressure and volume. And that's going to make sense more and more as you see the other 2 or 3 formulas that we're going to use. So when you see this formula, you're going to understand that if it's written like this and not in a ratio form, it means that when pressure goes up, volume goes down. They have an inverse relationship with each other. That's what he discovered through his scientific experiments. If volume goes up, pressure goes down. And you can understand that. You're going to see it at the end of the chapter, the section as well, that it's going to describe it according to the kinetic theory of matter. But look, if you put more pressure on something, okay, like let's say that we have a gas inside of here, right? If we put more pressure on this, what's going to happen to the volume of where the gas is? It's going to get smaller because you're going to be able to compress it down, right? If you allow this volume to get bigger, you make a bigger cup, what's going to happen to the pressure? It's going to be lower. Those molecules can go wherever they want. So the difference, the relationship between pressure and volume is that when pressure goes up, volume goes down. When volume goes up, pressure goes down. It's an inverse relationship, okay? That's Boyle's law. You can see that on a picture on page 90. So you need to give me 5 sentences about that with the formula explaining it. What's the relationship? You need to give me 3 sentences on Boyle, okay, who he was. Now let's use the formula for example 4.3. Okay, a sample of gas occupies 2 liters, that's my volume, at a pressure of 101.3 kilopascals, approximately atmospheric pressure, what is the new volume if we increase the pressure to 500? Okay, guys, if we're going to increase the pressure, this is not squared or anything like that, it's just P is the second volume. If we're, look what happens. We increase pressure, so what should happen to our volume? It should go down. So let's check and make sure that we get it right. So we have 101.3 times 2 is 202.6 equals 500 V. So then we're going to divide off the V, 500, pardon, and V equals 0.41. So what happened to volume? Did it go down? Yes, it went down from 2 to 2.41. And that's exactly what should happen with Boyle's law. Okay? Look at the practice, 4.2a. For the following questions, assume the temperature is constant. When you see assume the temperature is constant, that means that you're using this formula because temperature is gone. If a pressure of 73 is reduced to 11, what ratio expresses the pressure change? I'm not really sure what they're asking here, but we can just say what's going to happen. If the pressure goes down, which it is, the volume must go up. Number 2, if the pressure on a gas quadruples, that's times 4, what should happen to the volume? It should, guys, it should be a quarter of the volume. If the pressure goes up by 4, the volume must be divided by 4, okay? It must be a quarter of that. So that's number 3. If the volume of a gas doubles, what happens to the pressure? It should be cut in half, okay? If it goes up by 2, it should be cut in half. Okay, a mass of air has a pressure of 100 kilopascals and a volume of 200. Okay, it has a pressure of 100 and a volume of 200. If it is compressed to a new volume of 80, what's our pressure? So, volume decreased, so what should happen to pressure? It should increase. Let's see. We're going to divide this by 80. 100 times 200 divided by 80. Your pressure should be 250. It went from 100 to 250, so it did increase. Okay? Now let's talk about Charles' law. Here's another scientist that came around studying gases, studying the relationship between pressure, temperature, and volume. And he found that if you keep pressure constant, that volume and temperature have a direct relationship. Okay, so you need to write 5 sentences about this one as well. They have a direct relationship that means that if volume goes up, temperature goes up. They're not opposites. They have a direct relationship, not an inverse. If volume goes up, temperature goes up. If temperature goes up, volume goes up. Okay? So that's what we need to understand there. So let's look at example 4.4. A sample of gas has a volume of 2 and temperature is 273. The sample is heated to 373 while the pressure remains constant. Find the final volume. So here we go. 2 over 273 equals V over 373. So we're going to crisscross and multiply. And you're going to get 2.7. Volume increase. Because as this increases, this must increase. Okay? So look at Charles' law and absolute zero. All you need to know about that is that, I'm not going to make you write about anything there unless you want to include it in your 5 sentences. This formula, V1T1 equals V2T2, must be with the temperature of Kelvin. Okay, it cannot have a negative temperature, so we cannot use Celsius or Fahrenheit or anything like that. It must be a absolute temperature of 0, which is Kelvin does that. Okay, look at the next one, Amundsen's law on page 92. You need to write 5 sentences about this one. This one is when he was studying the the relationship, he found that also pressure and temperature have a direct relationship. So it's only pressure and volume that have an indirect relationship. Pressure and temperature, if pressure goes up, temperature goes up. Well, we learned that at the beginning with the kinetic theory of matter, that as we heat up molecules, right, they're going to be bouncing more with each other, okay, and that could cause more pressure. So as pressure goes up, temperature has to go up as well. Okay, so look at example 4.5, and it also must be in the Kelvin. A 2-liter gas sample, wait 1 second here. A 2-liter gas sample at 273 kelvins is put into a rigid container that will not permit expansion or contraction. So even though they gave you the volume, look, they said that they kept it constant. A 2-liter gas sample at 273 Kelvin is put into a container that cannot be expanded or contracted. So volume is constant. When volume is constant, we're going to use this because volume is not in the formula. But it does say that the temperature is 273. It's raised to 373. The original pressure is 101.3. So what do you think is going to happen to the pressure? It's going to go up, right? Let's crisscross and multiply. 373 times 1.1.3 divided by 273, which is 138. Okay, there is your new pressure. So look at practice 4.2a. You have to decide what formula you're going to be using. Okay, so we have, let's write our formulas up here. Boyle's law, P1 V1 equals P2 V2. Charles' law, which was V1 T1 equals V2 T2, and then Amundsen's law, which is P1 T1 equals P2 T2. Okay. For the following questions, assume that the pressure is kept constant. So for 1 through 3, the pressure is kept constant, so we're using Charles' law. If the volume of a gas quadruples, how does the absolute temperature change? It also quadruples. We talked about it. It's a direct relationship. If one thing is multiplied by 4, the other thing is multiplied by 4. Number 2, if the absolute temperature of 1 liter of gas decreases by a factor of 2, what will be the new volume? It will be decreased by a factor of 2. Okay? If the temperature of a 3 liter of nitrogen gas is raised from 200 to 300, what is the new volume? That one we could do right here. Look. 3 over 200 equals volume over 300. Crisscross and multiply. 4.5. Okay? So for the next questions, assume that the volume is kept constant. So now we're going to use this one, where volume is not included. If the pressure of a gas doubles, how much does the absolute temperature change? It doubles. Again, this is a direct relationship. Remember, direct, and inverse, this is the only opposite one. Number 5, if the absolute temperature of a gas with a pressure of 60 decreases by a factor of 2, what will be the new pressure? It will be decreased by a factor of 2. Next one, number 6, the air in a car's tire is at a pressure of 340 and a temperature of 17. Okay, so 340 and temperature of 17. Oh, no, we can't do that. Let me see if they're going to ask you to do any of that here. Okay, we're going to have to convert, remember we're going to have to convert Celsius into Kelvin, so let me get that formula. It actually should be really easy, but let me get that formula up here for you, because look at the number 6. You're going to have to, first of all, convert the 17 Celsius into Kelvin in order to do this problem. Okay, the formula is Kelvin equals Celsius plus 273. So if the Celsius here is 17, then we have to do 273 plus 17, which is going to give us 290. Okay, so it says, after the car is driven, the temperature of the air has risen to 46, so that's going to be 273 plus 46, which is 319. So So what is the pressure of the air in the tire? So this went up, so this must go up, crisscross and multiply. It's going to be 319 times 340 divided by 290, which is 374. Okay? So let me review because I have one more theme to give you and then we are good to go. You need two sentences on compressibility, 5 sentences on Boyle's law, 5 sentences on Charles' law, including the formula plus the relationships between the things and the gases, 5 sentences on Amundsen's law, and, 3 sentences on Boyle himself, and page 93, 5 sentences on the gas laws and kinetic theory, because what they're doing is they're explaining Boyle's law works like this because of this part of the kinetic theory. Charles' law works like this because of this part of the kinetic theory, and Amundsen's law works like this because of this part of the kinetic theory, and it's important for you to understand that. Then do section review 4.2. Thank you so much. Have a good day. Bye.